time t. Okay. F represents displacement. So this is different than distance. Displacement and distance are not the same thing. Sometimes they're the same, but they don't have to be. Can anybody tell me the difference between displacement and distance? Say one more time, displacement.
Can be negative.
That's true.
Distance can be
Okay, that's an important distinction.
Displacement is how far you are from the starting point, or what you're doing. Distance is just how far you travel.
Correct. Exactly right. Which means also, as Sariti said, the distance is not going to be negative. It's how far you travel. The displacement could be negative because it is where you are in relation to home, whatever the starting point is. Okay. So I could drive home right now and come back. Let's say I live 5 miles away. All right. Let's just say I live 5 miles away. What would my displacement be if I traveled 5 miles to home and then came back? What would my displacement be? Zero. I'm where I started. I made no displacement from this location. I'm in the same place again. But what's the distance traveled? 10. Okay, very good. Fantastic. So S is a displacement function, not a distance function. It tells you where you are, not how far you have gone. Okay? Okay. Fine. Velocity. Velocity is the derivative of S. It's the rate of change. Okay? With S with respect to t. So ds dt. Remember that S is a displacement, so it's measured in some sort of distance. T is time, so measured in hours, minutes, seconds, something like that, some sort of time. And anytime you have a displacement that is a what did I say?
Velocity.
Like some sort of displacement versus time, right? Some sort of length versus time, like miles per hour perhaps, or if you're in some other country, kilometers per hour perhaps, you have a velocity, right? Okay. Velocity function is the first derivative of S. However you want to write it. Prime of t, you can write it like that, either way. They use V of t, but you want to know what it is in terms of S, okay? It's its derivative. Then there's acceleration. If you do not know the units of acceleration, then it will not be so obvious that it is the second derivative of S. So when you denote a second derivative, that is, you take the derivative twice, right? It will look like this: d2s dt2, okay? You have differentiated, you have taken the derivative of S twice. So in the tick notation, prime notation, it looks like that, but that also means it's the first derivative of velocity, but they denote it with an A. So all these symbols down here are interchangeable, okay? I'm trying to tell you the relationship between the three things, okay? Any questions so far? Let's write the units for each one. S. Measured in some linear distance, right? Some linear displacement, some linear distance, right? AKA length, some sort of length. The derivative is going to be length versus time, right? Even if the number comes out to be 5, its units are still a ratio, length versus time. Right? Displacement versus time. Speed, but it has direction, so it's velocity. Okay? Speed has no direction. Acceleration will be length. You tell me, what's going to be? Think about what this is down here. Time squared. You've taken the derivative with respect to t twice. So it's S, the original units for S above, but the original units for t down below twice happening, right? So distance, or displacement versus time squared. Acceleration is always distance per time squared. Distance per time. Any questions so far? Just facts on the ground. Take the first problem then. These are pretty easy. 11 through 16. Most standard position, velocity, acceleration problem. We'll take number 11, the first one. 11. The function is t squared minus 4t. That's s of t. Leaves f, but I'm going to use s. 0 to 5. T, the time, is only defined for 0 to 5. Nothing less than that, which makes sense because it's time. It should not be less than 0. No such thing as negative time. I won't hear any physics mumbo jumbo either. No such thing as negative time. Right? And they're stopping us at 5 because they've chosen to. The first thing we're supposed to do is graph the position function. Okay? Part A. Graph the position function. Well, that's the function they give me. S represents the position function. Okay? So can you graph t squared minus 4t?
Yes.
Okay? Tell me how. What's a very basic way to graph this thing?
You go down, t equals 0.
So go down from where? From the origin?
Yep, 4.
4 units?
Yep.
You're positive about that? I'm
Yeah.
hesitant.
You won't stop,
Yeah,
right?
yeah.
It's at the,
So it does 0.
it stays right there. It moves left. No, doesn't it move left?
Oh dear.
Oh wait, no, but it stays at the center, right?
Well, let's just do this. Let's do what I want to do. Let's see. So let's factor t squared minus 4t. Since it looks easily factorable. T squared minus 4t is the same as t minus 4. If I set that equal to 0, it will tell me where this thing has t intercepts or x intercepts, right? Horizontal intercept. So this is t and this is s of t. Then at 0, right? At 0 and at 4, I have t intercepts. 1, 2, 3, 4. So those two dots are on this parabola. Okay? So let me ask you a question. What is the t coordinate for its vertex? What is that? What is the t coordinate for its vertex? You know that these two dots live on the parabola. Does this parabola open up or down?
Up.
Yeah, up. Because the leading term is positive, right? It opens up. And parabolas are symmetric objects, right? So if I have a value over here, this is the same, right? 0, 0, 4, 0. This is the same. And it has to be symmetric. So what t value lives in here?
2.
Good deal. That must be the axis of symmetry. Which means it's also the t value of the vertex. Alright? So now, if we know the t value of the vertex is at 2, what is the function value? Well, I'll plug 2 back in the original thing, right? I'll find s of 2 just to find out where the vertex really lives. 4 minus 8 is negative 4. So 1, 2, 3, 4. So there's the vertex right there, down at negative 4. 2 comma negative 4 is the vertex. And we know it has to slide up through there and slide up through blast. And slide up through there. Now, it's only defined for 0 to 5, so we have a small problem. We need to truncate this picture a little bit. I truncated it properly on the left-hand side. It only goes to the 0 location, right? Flows through its vertex, and then goes through 4 comma 0, and goes until what? Just until t equals 5.